All right, so beautiful. Okay, so what we were discussing over here is we are going to uh, implement these things over here, right? So before that, let's understand what we will do. We'll use Arc and Mutex. And why are we doing this? Because Arc and Mutex are the way of working around with, a thread safe way to work around with multiple threads. All right. And the mutex provide a kind of lock that prevent the data race, because so that no two threads can access a data thing at once. And few things to note over here is uh, let me know how is the audio and video. All right. And if you're new on the channel, or you just see watching the stream, make sure you like it. And the polls are on your screen, so just opt for the polls. All right, few things over here that we are going to learn today. Arc and Mutex. Arc is the thread safe version on RC. RC is reference counting, and ARC is atomic reference counting. So what Arc does is it help us to have the shared ownership of a specific type, or if we are like kind of working around with the multiple threads. Okay, so as you can see it over here, atomic reference counted and mutex, mutual exclusion, are the standard Rust primitives for safely sharing and mutating a data across multiple threads. So because we are going to deal with multiple threads, so we have to make sure that our type, whatever we are using, should be equipped and should be able to work around with multiple threads. So for that we will use Arc and Mutex. Hello everyone. So if you are watching this stream, make sure you leave a like, and the poll is already there on your screen, as you can see. And if you are like kind of just watching it and don't want to see the chat, you can disable the chat. I'm just saying it, right? Okay, and let me know if you have anything on your mind. The chat box is open, and we are going to learn today about threads, arcs, mutex, and how do we work around with multiple threads, and how do we beat the bush around it. So arc enables multiple threads to hold shared ownership. Okay, I have made some point over here, right? Why are we going to use, and why we are like kind of reading this? Because this exercise that you can see on your screen, let me just do. Oh man, I'm getting the call. Just wait. Just wait, all right? All right. What's that? Let me just. Okay, we are good. And yeah, this one. Yeah. Okay. So yeah. Uh. So what we were doing is we were working around this thing, multi-threaded word counter, right? So this was the fifth exercise that we were doing. So what it says is we have to read a text file, split the work. That's the secondary thing. Split the work across multiple threads using thread, a standard like this thread, and arc and mutex. So basically, it helped us to understand what we have to do. Okay, to aggregate counts. Now do this before touching Tokyo. Is this okay? That is the thing. So the example is over here is, let's say this is the text string. Okay, so we have to figure out how many times a word occurred. All right, so it's a classic question as well that comes on the interviews, that how many times a word has been occurred. So as you can see, the string over here is the quick brown fox, the lazy dog, the. So the appears 3 times. So first, second, third, right? And all of the other things are one time, quick brown fox, lazy dog, right? So we have to kind of read the file. That's the core purpose of the exercise over here. But for an example, we will do this. So what we did yesterday, what we did is we created this thing. That was the basic implementation, and we just wrapped it in arc and mutex because we are on to the next step of this exercise, right? So we implemented the basic thing. We have we had a hash map, and we figured out a way to count the word on that specific line, and we just return the counts, and that was working. But the goal here of the exercise is a different thing. It wants us to teach about the threads so that we understand why the need of any async runtime was there. Okay, to understand the need of async runtime, we have to understand why was it in the first place. So for that, we have to understand about the concurrent programming, and for that we have to understand how threads works. All right, so we'll deal with threads, and to work around with threads or multiple threads, we have to follow something, right? We have a standard practice, and what is that? We have to wrap any type, okay, that we want to share in between the threads. We have to wrap it in arc and mutex. And what are arc and mutex? As you can see, arc and mutex are rust primitives for safely sharing and mutating data across the multiple threads. What does this mean? Arc is the atomic reference counted. It's a thread safe version of a different a primitive called RC, that is reference counted. If you really want to understand about this thing, you can directly go onto the official Rust book where they have like kind of brushed on these things, right? With some exercise as well, with the debugged messages and all. Okay, so we have to use these things, and let's understand what are arc and mutex. So arc, basically it enables multiple threads to hold a shared ownership of the same data by incrementing a reference count automatically. Okay, so there is a data, and if you want to share between those threads, okay, so we have to have the ownership shared, right? Because whenever we spawn a thread, it kind of take the ownership, so we move the ownership. So this way we have the shared ownership of the same data. Okay, and arc do it by incrementing a reference count. Okay, how many counts, how many references that particular data holds, it increase the counts, right? It ensures that like data remains valid at as long as at least one reference exists. Okay, it is a thread safe equivalent of RC, and it allows cheap cloning of pointers without deep copying the underlying data. Okay, and mutex. So you understand the need of arc over here, because we are going to work with threads, so we need to make sure that all the threads have a shared ownership of a specific data. So we do an arc, and inside arc we'll pass a mutex. Mutex means mutual exclusion. It's also a Rust primitive. So what does it do is it provides the access to a data it wraps. Okay, so whatever we wrap inside a mutex, it provides the access of that data, and the other threads that are working on it, they need to acquire a lock, so that other thread cannot mutate that data for the time being, so that it prevents a data races, the issue of data races, right? Data race means a single thing has been used by more than one you know resources. So this prevents data race by requiring threads to acquire a lock via lock method before accessing the value, which is automatically released when the guard goes out of scope. So these paragraphs we have like kind of encountered multiple things. If you are new to programming, you must be wondering what is a scope, right? What is kind of drop? What is a drop, right? What is a lock? So yeah, so I think it's not very beginner friendly, but it is very kind of important thing if you are learning Rust. Okay, and this thread and concurrent programming is one of the loved topic of anyone who is learning Rust. Okay, now these two are independently are just the primitives that have some features, but it becomes powerful when we combine these two. That's what we did over here, right? We have a type, a data structure over here, a hash map, right? It has a key and a value. Okay, the hash map itself alone was just a single data structure. All right, we can just update it, mutate it, but if we wrap this hash map around arc and mutex, it becomes something else. Now it's ready to be passed in between the threads. Okay, so if I go over here, you can see when combined as arc and mutex, they allow multiple threads to safely share the mutable state. Now this is the primary pattern for concurrent programming in Rust when interior mutability is required across thread boundaries. So here is an example over here, as you can see, a basic simple counter that is going to be passed in between the threads, so that the multiple threads we will create over here, they will try to increment the counter variable, right? So initially it's the value is 0. Okay, and we have wrapped this counter, this integer, into the arc and mutex, right? We have initiated arc new, we have kind of initiated a mutex, and we have wrapped that default value 0 around arc and mutex. Okay, and why we created this handle? See, before watching this thing, like what is arc and mutex, I hope this is like kind of pretty much understandable why we use arc and mutex. But you must be wondering, like, okay, arc and mutex are fine, but what are threads, right? What are threads? Why are we keeping these handles, right? So let's go over here on this section, threads. Threads in Rust are native operating system threads. All right, so every operating system has some threads that process things. Hello. What are you doing? Nothing. I'm just like kind of solving an exercise that will help to understand topics that usually we skip those things while in theory, right? So by building projects, these points, they get strong. So that's what I'm doing. So guys, if you're watching this stream, make sure you leave a like. That would be good. And the votes are kind of doing this. You need to use protection. You can't be like this anymore. What? Let me pull the chat over here so that I can see. Yeah. Okay. So threads in Rust are native operating system threads. So the operating system that we use, it has threads, it has a thread pool, and whenever we kind of create or ask our operating system to do something, a thread is assigned, and that thread do the executions, right? And there are multiple threads so that they can work in parallelly. Okay. So one-on-one threading model where each language thread correspond to one OS thread, allowing to concurrent execution and parallel processing across multiple CPU cores. Okay, so let's don't like we don't have to like diverge here and there. Threads in Rust are basically spawned by there is a crate provided by the standard crate that has spawn associated method, right? So we can use that thing, and it accepts a closure. So what is a closure? If you are from JavaScript background, you must have kind of heard this thing, right? Closure. We provide a closure. There are multiple questions, interview questions that are being asked around the closures. So Rust also kind of has these things. We'll see how it like how we create a closure, how the closure works and all, right? So Rust also has the functions like slice, splice, filter, you know a map. So they accepts closures, right? Basically these are the functions that you want to so thread.spawn, it takes a closure. So it takes a closure, and the thing about closure is it needs the ownership. Okay, so we have to move the whatever we are going to work around with the data type or data structure. Okay, it takes the ownership, so we have to basically do a move okay. So Rust enforces thread safety through ownership and borrowing rules, using move closures to transfer data ownership into threads and primitive like this. Okay, so that's what we said. We have to use this move keyword in front of a closure so that we can transfer the ownership into the threads. Okay, but I usually cool. So yeah, we'll do this thing. Standard thread spawn will do. And one of the important things over here is dot join. So whenever we will assign or spawn our threads, we have to basically create this function called dot joins. If you don't do this, the program will simply exits. Okay, so and what does this join returns? It returns a result that has the okay and the error values, right? If there is an error in any of the working of the threads, then we'll kind of catch that thing, and if all goes well, we'll handle that in okay. So here are some notes that I created. Arc and mutex. So basically these are the patterns that we have to remember while working with multiple threads around a thing, right? So we'll have to use arc and mutex. So basically you can kind of make a mental model around these things if you have to work around multiple threads. Okay, so you have to use arc and mutex. And arc, it is a thread safe version of RC, and mutex, it's a mutual exclusion. They both are the primitives, Rust primitives. Together they can be very powerful if we have to like share the data between the threads. All right, and mutex provides a lock so that each thread have to acquire lock before like kind of working, so that it prevents the data races, so that no two threads can kind of work around a single thing. And we have to wrap them in arc and mutex if you want to make any type or data structure thread safe. And once we spawn these things, we have to call this join handle, this join method, right? So on the handle, otherwise the program execution of the thread finishes the work, and join returns a result with okay and error values. Okay, I hope this makes sense. And yeah, and this example over here, we just left it, right? We'll continue with that. So this documentation is about the threads. What all methods do we have? And yeah, this is the official Rust book that tells about how to spawn a thread and how to transfer data between threads and message passing. Basically, message passing is a different thing. We have to use channel so that we have to pass message in between the threads, so we have to use the channels, right? So that's not a thing. So maybe if you can go back from here, you can see about things about thread. Yeah, using threads to run code simultaneously. So this chapter over here is quite good. It tells about how to spawn thread and what is the reason of this closure. We have to move this thing, right? So this is a closure, as you can see. Thread dot spawn, it takes a closure, and this closure has to take the ownership of this thing. So we'll have to kind of move this thing. Okay, so we have to use this thing, otherwise it will throw an error, right? The error is over here, so we have to use the move keyword around here. Okay, now let's come to our own problem in the exercise. So we have to make this simple version a thread safe version, and we have to use threads. So again, I'm telling you, for a simple kind of sentence like this you won't like kind of hardly notice any difference by using threads. Okay, it will be very easy. It will be very easy. And but the noticeable difference you can see is if you use a very big file that has multiple lines that you can, you know, check. Okay, how many people are watching? All right, so yeah, let's go to the example that we just left. Okay, so we have here we have a counter that is being wrapped in arc and mutex, and we created a vector of handles, and we'll keep pushing on the threads handle onto it, and then we can always, you know, at the end, that is the mandatory step, is to call join on those handles. Okay, because we are dealing with multiple threads, so we have to keep track of those handles. So vector would be a good choice over here, so that we can push each of the handles on the vector and later on call the joins by using a loop. Okay, see, this is the pattern, guys. Okay, so here it hard coded and spawned like kind of 5 threads over here. Basically these threads could also be generated by using the methods provided by the crate, the thread okay, standard function that we have in the standard crate, right? So we can always look for that. I really don't like kind of remember that thing, but again we have to like kind of understand this thing, and other things we can just search it on, you know, web. Okay, now you can see we have to clone the arc as well. Why are we cloning this thing? Because each of this kind of, you know, because we are like kind of passing the counter in it, right? And this counter has to be cloned because it will take the ownership, right? As I already said, the spawn, the closure that we pass, it take the ownership of this thing, right? So to take the ownership, we will clone it. Okay, we'll clone the arc again. The good thing about that, we really kind of read it just few moments back, is it doesn't do any deep copy. First of all, right, it will just copy the kind of references over here, right? Okay, that allows cheap cloning of pointer without deep copying the underlying data. Okay, so we have to clone this thing, we have to clone a arc, and we have to pass it on the thread. So it's a kind of a pattern that you have to keep in mind while you tackle these kind of, you know, threading problem. Okay, you do a thread dot spawn. This thread dot spawn returns a handle. That handle has to be pushed on this vector because we are like kind of, we have the multiple threads, right? And again we have to call joins on all. So to call joins on all, we have to keep track of these handles, like multiple threads, right? And the best way is to push it on the vector so that we can have a collection, and that we can iterate on that collection and call join method on each of the handle, right? Thread.spawn all, okay. And now the mutex come into the picture. It takes a lock, okay. This counter clone, this arcs clone, it has to acquire a lock before mutating a value, okay. That's what mutex guarantees data races, right? You have to take a lock of the of that variable, right, and then mutate it. And once this closure goes out of scope, the lock automatically drops, okay. So if you have kind of read about few basics of the Rust programming, whenever things goes out of scopes, it calls drops automatically, right? So drop is a function that get called automatically. You can kind of create your own drop in the impl block, basically, right? The way you create a implement a display trait. Okay, so the drops get called once this goes out of scope. The locks gets released, and the next thread can again take the lock, and the same thing goes for this entire group of threads. And finally, you just call handle.join, because that's mandatory. If you don't do this, once the thread kind of process things, the program simply exits without you like thread doing the actual work, basically. Okay, so you have to call handle.join. The join returns an result of okay and error, right? It returns a result that shows whether it's an error or something. So some bad things are done over here, like unwrap. So because these returns results, so we need to like kind of do pattern matching over here as well, because we will do this thing in a separate file, so we can always propagate the error to the main file from where these functions are being called. I think this is enough for to understand how to do our exercise. So let's get into it. If you have any questions, feel free to ask. I'll just wait 5 minutes or maybe 2 minutes. Let me check the polls. Okay, 5 votes for now. 60% of you guys are not into programming. That is good. You can always like this stream. Anyways, if you have any questions, if you are not liking the stream, make sure you let me know. And if you are into tech, the chat box is open. We can always chat. And if you have any doubts, anything related, also you can tell me. Are you a working professional or a student? And if you want to ask questions like from me, you can do that as well. Okay, so I think we should get back to it and start implementing this thing. Okay, let's first of all see how our problem is. I hope we understand the purpose of arc, mutex, why we use them. But before that, let's understand our simple thing. So this was our, you know what, should I create this thing? Let me just create another. Okay, let me delete this thing so that you guys can simply okay, now I'm just doing from the scratch. Okay, why I'm doing this from the scratch? Because we need to understand how we simply created a simple kind of thing first, and then later on we just implement a thread implementation to it. Okay, so the project says something like this. It says we have to count the occurrence of each of the word from a single sentence, and we have to use hash map for it. we are not going to do everything on the single place over here, so let's create few modules over here. I'll call it counter. Inside this I'll call main, and again another file called counter, right? On the main, what I'll do, I'll say pub mode counter, right? And let's go on the main and import this module over here. I'll say mode counter, right? Mode counter, cannot find counter. Why is that? If I go, oh, it's not main, man. It's not main. It's mode. It's not mode. Okay. And if I go inside mode, I have a mode counter, and let me just go on the main. I think I will be able to do this now. Okay. All right. So I have this counter. Now let's go inside it and start implementing, right? So we need to have a hash map, right? So to have or created a hash map, we'll use struct over here, right? I'll call it counter, and I can just say public. I can have it a store, right? I'll say public store hash map. Let me just import it. Okay. So hash map will have basically key and a value. So I can have string as a key, and for the counter, we can have view size, or you know what, unsigned 32. That is fine. Oh my god, view 32. Okay. So this is our counter struct that has a store, that has a hash map. So we are just implementing the basic thing over here. All right. Let me just check this thing as well. Okay. Now let's write our impl block, right? Impl counter, and over here we need a associated function. So let's call it new. Okay, it will return a self, right? And because it will return a self, so we have to initiate this thing over here. So we can say counter, and over here I can always have a store or and hash map. And how do we initiate this thing? We'll say new, and inside this I'll do nothing because this is the way to initiate a new hash map. Okay, so the new associated function is being created. Now why I'm doing this? Because I have to take the reference of this struct so that I can mutate this hash map, and after mutating the hash map I will just have the counter of those specific words with me, right? Just give me a minute. Whoa, 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 whoa. It's leaking. Okay. So here we are going to implement some other functions as well. Let's say uh, read. So we have to implement read text, right? And what is this? It is a function, right? And it takes a mutable of self. Why I'm doing this mutable self I'm passing so that I can access the struct over this module. And mutable self means I need a mutable reference of the self because I have to update the store, right? I have to update the hash map. And if I want to read the text, I should have a text, right? And this text should be of type string, right? And what does it returns? I want to return the string, right? Whether it's an okay or not. But if you are really going to kind of control everything, right? A result, an option and all. So I want you to return result from here. That would be a good thing, right? I want you to return result from here. So how do we return a result? I'll say result, right? And a result have basically two things that we have to, pass. The one is the error and the other one is the okay, right? So for the okay, what you can do, you can just pass in the string, right? Whether just a representation of whether the text has been read or not. I hope the audio is fine. Is it? Is it good? Let me know, guys. Is it good? Maybe I can just have it over here, you know. I think this will be good, right? Okay. So the first thing is an okay value. The second thing is error. So we have to understand few things over here. This is a very important thing that most kind of beginners stuck into it. So let me just clear it over here as well. You see, you like kind of will see this pattern when you are working with web development or any web dev library like Exam or Actix or something like that. What does it say? It says this function is returning a result that has an okay value or an error. And this error specifically here, if you focus on this error is currently at this moment of the time, this is a simply error, like standard IO error. Okay, but what if this function read text have multiple things, right? A function can have a multiple set of instruction and each set of instruction can do its own task, right? So own task means it should have its own error as well, right? So let's say this read text, basically it will read a file and then it will again split those text file into the white spaces and then again kind of let's say take a log from a mutex hash map on something like that. So basically three different operations, and if each of the operations or any of the operation fails, it will have a three different kind of errors as well, right? So to deal with that, this error over here, you have to wrap it in box. So again, if you really want to understand box deep into it, like you have to kind of go through the Rust book. But few things that I can tell you over here is box is basically, I mean, in layman's terms, I can tell you, let's say this is a data structure I have. Okay, not a data structure, anything like a type or a data structure, right? Any type, let's say for now. So this is a type. Okay. Now, if I, if this is an error type, let's say, and there is a function called read text. Okay. The compiler now, by seeing, compiler cannot get kind of figure out what kind of this error will be, because there are multiple set of instruction on a function, right? And to do that, to make sure that compiler, okay, give us some relaxation that what kind of error it is, we wrap this error around box. Okay, why box? Because box will keep this error, will put this error on the heap where we don't have any size restriction, because we don't know the size of the return type of this error as well. So we have to keep this in box, right? Box put this error on the heap, and we have to use a keyword around for this error is the dynamic, because compiler at the kind of when it compiles, it doesn't know what type of error would be, and it doesn't know the size as well. right? So that is why, to kind of ensure the compiler that we know, as a developer we know, and we are telling the compiler that okay, I know what I'm doing, so I'll use boxed in and then I'll use error. So you will see this thing in most of the if you are doing a Rust programming, right? You should have seen this. So this is the purpose of boxed in over here. So, and how result is written, we return it okay if everything is well, return a unit type. But for now we have to return a string. So just to trick the compiler, for now we'll do this, right? It's all good. Compiler is kind of saying okay, we are good, buddy, right? Now let's do some other things over here as well. What does a read text do? So I have a text, right? Now I want the text to be, because in order to calculate how many times a word occurs, right, occurrence of a specific word, I need to iterate on that string, and to iterate on that string I have to be like, it have to basically, it should basically implement the iter thing, right? And we can do it by collecting this string into vectors, and to collect that string into the vectors, uh, for easy to understand, I must say, if you are from a Java, like if you are familiar with JavaScript, and if you have a string, how do you collect it into an array? If it's a space separated or comma separated thing, or a piped separated thing like that, you just split that string based on that specific filter, right? So the filter over here, as you can see, is a white space. So this, we have to kind of break this string on the white space, right? So I can say let split splitted string equals, I want it to be a vector, right? Vector of string slices. So what it does, I'll say text dot split split white space, right? I have a function, okay, split white space. What does it return? It returns a split white space. Now I have to kind of collect it, right? Let's collect it. And if you want to kind of trim that thing as well, those string slices, you can use map here as well. Map, okay. Inside this map you will pass an iterator. Inside this map you will pass an closure. That closure will make sure that okay, whatever you do inside that closure, that get applied to every item on that collection, okay. So I have collected this thing, and this collect will return a vector of string. So whenever you doesn't know what type it will return, you can just simply go to the function definition, right? If I click on over here, you can see that collect is basically, I don't know if you are able to see this. Let me just go inside this thing, because we are on the mobile view. Okay, so this is my collect function. If I go into the definition, it implements from iterator trait, right? And it returns b, okay. I just want to show that what it returns. Basically it returns string slice if we are working with if we are just splitting the this thing. So collect, basically it returns a vector, okay. So let's go again on the counter, okay. So this is how you collect string slices if you are working with strings, right? So I have the string slice over here. Now what I'll do, I'll just loop it on, right? I'll loop on it, loop on it. And how do I loop on it? I can simply use for item in a splitted string, right? I can simply say this, and now I have the item. So let me just show you by printing on it. I'll make sure it gets pointed to the new line, and I can just say item over here. Okay, now let's see what do we get. Okay, we haven't called this thing on the main, right? So let's go on the main, and hello world, I can just say counter. Okay, let's provide a new line over here, and I have to call this thing, right? So I'll say read. Okay, no, I have to get the that thing as well. So I'll say let store equals counter, right? And I'll call the new associated function that I created. That's a pretty common pattern if you are like working with any object oriented language or anything, right? So you have the instance of new, from that you have kind of a reference of that class, right? So the struct that we have created over here, the template, by using this associated function, we are returning self, right? Inside the new associated function that we created, it returns a self. Now why we need self? Because we need to mutate the hash map inside that. Okay, so to mutate the hash map, for now we are not getting any error of like kind of use the mute keyword, but definitely we will, because we are going to update the counter of each of the word, right? So we'll tackle that thing. We are not going to judge it early. So I'll say store dot read text. Okay, inside this thing I will pass in the text. So let me just copy this thing. Okay, I'll just paste it. Now to make this thing a string, I will simply just do this. Okay, now here is the thing. If I go inside this function's definition, you see what it does? It returns a result of a string and a den error. Okay, now here's a very good thing that we are going to learn. We are going to learn how to handle this thing, how to handle a result, and how to do this thing. See, I can do always this thing, unwrap, the error will be gone. Cannot mutate a immutable variable. See, I have to use a mute over here. Why? Because this read text has been taking a mutable reference of this thing, right? So if I don't want to mutate store, then I have to use and self, and this error would not be there because I use the mutable reference of self over there. So it is kind of thinking that okay, this read text is taking a mutable reference of self. That means something is going to be mutated there, and the store is the only thing that will be like that thing will be updated. So like that. Okay, see, the error is gone as I use unwrap, but this is not the way to do. Oh my god, it's raining. Noise. Oh my god. Uh, uh. Ooh, we have 4 likes. 4 likes. Come on, guys. Make that thing up to 10. 10 likes. Come on, people. If you are just visiting, it's okay. No problem. Just leave a like. Okay, but this is not the way to do so. We cannot kind of do this thing, unwrap, right? Here, if anything occurs, the program just kind of, not a graceful way to do so. So how do we do that then? Whenever you see things like this, you have to basically use a match statement here, right? So basically I'll have to do a match over here. Why I'm doing this match? Because a result will have either the okay value, okay, or the error. The beauty of result over here is it will have either the okay or the error. So if we do kind of pattern match on these things, like if it's an okay value and an error, we can basically handle the errors very gracefully. So if it's an okay, what I'll do, definitely I will have some response over here. I can just simply print the response, right? Because I'm returning the string over here on the OK value. Okay, so I can just say println, and I can just print the result, right? I can just print the result, right? And on the error, what I'll do, I'll just print the error, right? So let me just copy this one. Okay, and in terms of here, I'll just use E, and I can say error. See how instead of using an unwrap, I kind of uh, pattern match on that result, and either it will have an OK value or an error value. Now if the error comes, I can simply print the error, right? I can print the error, and if there is a thing, if it success, then I will just print the result. Let's go inside read. Okay, it is good. New is being used. Field is never read, store. Okay, yes, that is fine. Println item. Let's see what items we have. Are we able to split those things or not? Okay, and you know what I can do? I can just print all of these over here so that you understand how the raw text is, right? So I have the raw text, and I can just say text, right? And goes over here as well. Just copy this thing, right? And over here I can just show splitted string, right? Splitted string, and what else I need to do? Raw text splitted and the item. All right. Doesn't implement what? Okay. Okay, now let's see what's with this thing. Cargo run. It's building. So you see the raw text that I passed is this. The raw text that I passed is this, right? The quick brown fox, the lazy dog, the, and I converted and splitted the white space and collected it on the vector. I get this. This is the vector, right? And when I loop on the vector, I get all these things independently, right? Let me clear this thing. So we are on a track. Let's remove all these things. Now we have each of the item, right? So what do we have to do of this item? We have to check whether this key exists in a hash map. If it does, we have to increment a count so that we can have this thing, and if it's not, then we have to add that as well by the default of count of this thing, right? So what we can do, we can have a count over here, right? And we can have self dot store, right? Dot. So hash map has a method called entry, right? Entry. It checks whether a specific key exists or not, right? So the key over here is item, right? It will check. Okay, and it has another beautiful function over here. It says or insert. what it does, the entry function checks whether an item is present on a hash map or not. If it's not, it will insert its value as 0 for that key. So for now, the hash map is pretty much empty, right? It is empty. But with this function, it will check whether the item is available on hash map or not. If the item is not available, it will insert the key, that item as a key, and its value as 0. Why I'm setting the value as 0? Because the value is this U32, right? That's a pretty like big number. We definitely don't need that. But again, I'm just doing it. Okay. Let's see what an error over here is. If I do a cargo build, it says expected string, but I found a string slice. So we have the hint here as well to do toString, right? Compiler kind of, helps us to do some things. Okay, I hope this you understand this thing. This entry function we have is basically checking whether that specific item exists on the hash map or not. If it doesn't exist, it will just insert it, right? So we have an insert function on the hash map. So instead of doing very tedious thing like using a filter or using a if else filter and then doing store dot insert, okay, and then incrementing the counter by assigning the default value to 0, everything is done on this line. Beautiful, right? Store dot entry, check the item. If it's not available, insert that key and set the default value to 0. Okay, now here you can see, now this thing will return me the value of this item. Okay, this line, this function or insert, right, it will return me the value that is currently 0. So I need to increment it to 1, right, because the item has been encountered. Okay, so I have to increment it to 1. If I have a default value of 0, the item encounters, I'll have to increment it to 1. If it's already 1 or 2 or 3, I have to increment it because it has been encountered again, right? So what I'll do, so let's first of all see what insert returns. Okay, if I go inside this thing, it returns a mutable reference of a value. See the documentation never lies, so instead of directly jumping into the web and ask for it, we can always go on to the documentation of this thing. Okay, or insert function, right? It takes a default value. So basically or insert is used to set a default value, guys. Okay, and it returns a mutable reference of a value. What is v? It is a generic for value, right? So when you define hash map, you define k and v. It's a generic nomenclature that like we use in different languages like T. Okay, so for key and value we use k and v. So it returns a mutable reference of value. How can this help us? So if I go inside over here, read text, it returns a mutable reference, right? So definitely I'll have a mutable thing over here, right? Because I also want to mutate it. Because it's a mutable reference, I have to dereference it out so that I can mutate it, right? I cannot do simply count plus equals 1. It will say it is behind a shared reference, right? I can show you this. Okay, on type this you cannot do. You have to basically dereference it, right, using this star. Okay, it cannot be applied to type this because it's a mutable reference, right? So let's do this thing. Now I dereference it. The error is gone and we should have the hash map now with the updated values, right? So instead of this thing, what I can do over here, instead of passing an empty thing, I can just pass this thing. I can say self.store, right? I'm passing this in. Okay, it doesn't implement display trait, so I can do this, right? So let's see how it goes. We have some warning here as well. So if I do cargo build, it says remove this mute. Okay, it doesn't need to be mutable because we are dereferencing it, right? Okay, the error is gone. I can just cargo run. Wow, you see, the is 3. Now check this thing. The is 3, quick 1, brown 1, fox 1, lazy 1, dog 1. Lazy 1, brown 1, dog 1, fox 1, quick 1. The is 3. So this is the basic implementation. The goal is not this. This is the basic implementation. The goal is to use threading around it, right? The goal is to not do this synchronously. The goal is to make it asynchronous by using threads so that all those threads can work in parallel, right? To read a very big file. Okay. Just give me a minute. I need to relieve myself. I'm just capturing like kind of, this. Yo, yo. Okay. Yeah. So this is what we will do next. That was the whole thing from past 1 hour we have been blabbering about. So you guys have any questions? Let me know. Okay, we have 12 votes and most of them, 67% are into programming. That is good. So make sure you like this stream, and if you want to just, hang around, then chat box is open. Let's make this thing very engaging. Okay, let me create another poll. Oh, I can. So 69% this thing. Okay, let me just create another poll. Okay, another poll. it should go up, right? Earlier the poll used to go on top, but now they are here. Anyways, so let's do that. Okay. We already understand how are we going to do that. We have Rust primitives that are going to help us, right? That are going to help us, I hope. Yeah. So if you have any question, the chat is open. So move on to the next thing. Now the good thing over here. Okay, so the basic thing that you have kind of understand, right? How to create a template over here, basic template for a module. You create a struct, you do an impl, impl block. Inside the simple block, you append some of the functionality to this structure that you have created, right? And you create a new function that is an associated function. So one question over here is, can you guys tell me the difference between this read text and this new function? Can you tell me a difference? Come on guys, I'm waiting on you. If you don't know, just say no, it's okay. Come on, can you tell me a difference between these two things? It's pretty good question. Come on, come on, come on, come on, come on. Pretty obvious question. The difference between these two things. If you don't know, that is okay, but say something on chat. Come on, I'm waiting for 10 seconds. Come on, no one is judging you guys. Come on. Just wait, I'm getting a call. I am getting a call. Hello. All right, we have a guest in the room. Colin Maharaj. Colin Maharaj. Kabooliye sir. C++ programmer. Nice. C++ programmer in the Rust stream. Good. How are you doing, sir? Okay, so if you are finding something wrong with the stream, always tell me as a friend. All right. Any tips for the brother? Colin Maharaj, how are you? So guys, here's the question, right? The difference between read text and new, both functions. Come on. I have to go like in few minutes, I think. because so okay, just let me kind of uh, give you the answer. So you see, in the impl block we have two functions. See the signature around them. See the signature around them. The signature here is, they both are public function. But what's the difference? The difference is in the parameters. You see the parameters? One takes a self, another doesn't take anything. Another doesn't take self, and the other one takes self. Okay. So the function that doesn't take self are generally called associated functions, and these are simply called functions, right? Functions. Okay. So the difference is this. Important difference for you guys to note, right? From here there can be there could be multiple questions with these things, right? This observation over here, they both are public functions, but one takes self, another doesn't. The one who takes is a function, all right? The one who doesn't is basically an associated function. One more thing over here, associated functions are called by using double colon, you know so they are called by using this thing. You must have seen somewhere, right? If you are into Rust, if you read the code bases, you must have seen some functions are being called like this, while the other functions are called with dot, like the regular thing, right? So this is the reason on the main, if I go, I call the new function with this double colon, all right? And this read text function, I called it with a dot. Doubt, sir, doubt. Why? Because new is an associated function, it gets called with double colon, and read text is a simple function that is called by using a dot, right? Do you get it? Guys? Do you get it? The difference between new and read text, why this is an associated function, why it is called an associated function. Secondly, how do we call these functions? So the difference is in the calling. These function gets called differently syntax wise, and there is a difference of this self. The one who takes self is a simple function, the another one who doesn't is called an associated function. Basically they are both are functions, but the one who doesn't have self is an associated function. Do you get it? Do you get it? Let me know in the comments, guys. Come on, in the chat, of course. Let's make it more engaging. The chat box is open. Let me know what you didn't like in the stream. All right. And if you're just watching like for something, it's okay, no problem. Yeah, but you can always come on the chat, right? I can have this thing like pushed on GitHub if you want. Okay, so let me just pin few things over here. Here we are learning about threads, arc, mutex, results, match, pattern matching, right? We are learning about it. Let me just pin this thing. Let me pin it. Pin the message. All right. So I can see on the polls there are 3 votes. Guys, the poll is open. Make sure you kind of, pin it. Just give me a minute. Video. I'll have to go. I have to like pick someone. So I'll continue this thing. All right. On the next stream. So make sure you just be kind of in touch with me. For that, you have to subscribe. And once you do subscribe, you get notified about my stream. And we'll continue this thing. We'll read about it. Okay. Very nice implementation that we are going to do. Hello, Tiger. You are on the wrong time, bro. I'll just be back after like maybe after an hour. So we'll continue this thing. All right. It's urgent, guys. Bye bye. Thank you, everyone, whoever joined. Bye.